Welcome, welcome, welcome. This is Mrs. Radel back with another 8th grade math topic. Today we will be doing Module 1, Lesson 4. Today's goal: I will be able to simplify numbers raised to the exponent of 0. I will complete this goal by 1. Watching the video and taking notes in my module packet, 2. Doing the examples along with Mrs. Radel, and 3. Completing the problems on Nearpod during class. So over the last few classes, we have been talking about bases raised to positive exponents. So if we just wrote a general base with an exponent of n, we have only been talking about n's that are greater than 0. 1, 2, 3, 4, 5. And we talked about how we can rewrite this as x being multiplied by itself n times. So in this case, the n is 3, or it would be x to the 3. So today we're going to talk about what if n is equal to 0. So take a moment to fill out this table where I have it in your module packet. The powers of 3. 3 raised to 0, 3 raised to 1, 3 raised to 2, and 3 raised to 3. 3 raised to the 1 is 3 multiplied 1 time, so 3. 3 raised to the 2 is 3 multiplied 2 times. 3 times 3 equals 9. And 3 raised to the 3 is 3 multiplied 3 times. 3 times 3 times 3 equals 27. So make sure that your table looks like mine. And now we're going to use the pattern in the table to figure out what is 3 raised to the 0. So let's look at 3, 9, and 27. What operation, addition, subtraction, multiplication, or division, do we use to go from 27 to 9? We can do 27 divided by 3 equals 9. Let's see if this pattern works from 9 to 3. We can divide 9 divided by 3 and get 3. And so if we think that this pattern goes on forever and ever and ever, we could do 3 divided by 3 and figure out what 3 raised to the 0 is. What is 3 divided by 3? Well, it's equal to 1. So we have this rule that any base raised to the 0 equals 1. And go ahead and fill out the 1 in the table. It isn't math magic that something raised to the 0 is equal to 1. It's actually because if it was equal to something else, all of the rules and the laws that we learned in our last classes wouldn't be true anymore. So we have to have anything raised to 0 equal 1, or our laws don't hold up from before. Let me show you what I mean. So the first rule that we learned is that when we have a base x raised to m times the base x raised to n, we can keep our base of x and add the exponents. That has to work when m or n is equal to 0. So let's see if it does. So in exercise 1, go ahead and write 3 raised to the 3 times 3 raised to the 0. Now, if you saw this problem a few days ago, you would say, okay, Mrs. Radel, we are multiplying two bases, so let's add the exponents. So let's do 3 raised to the 3 plus 0. And what is 3 plus 0? It is 3. So we know, based on our other rules, that 3 raised to the 3 times 3 raised to the 0 needs to be equal to 3 raised to the 3. So let's copy this down. We know that 3 raised to the 3 times 3 raised to the 0 needs to be equal to 3 raised to the 3. We start with this number. We multiply it by something else, and it's equal to the number that we started with. The only number that we can multiply a number by and get the same number again is 1. So it makes sense that 3 to the 0 equals 1, because if we look, if we just erase the 3 to the 0 and make it 1, we know that 3 raised to the 3 times 1, anything times 1 is equal to itself. So 3 raised to the 3 times 1 will be equal to 3 raised to the 3. And so it must be true that the 3 raised to the 0 is the same thing as 1. It is equal to 1. So let's fill in our definition here. We know that with a base of x, which could be any number, or x, if we're going to raise it to the 0 power, it has to be equal to 1, or the other rules that we've learned won't be useful anymore. I hope that helped, and I look forward to seeing you all in class. Goodbye.